In this video, we'll discuss running the K-Means clustering function using UnifyML SQL. We use the UnifyML K-Means clustering algorithm through a UnifyML query. Here, we execute the UnifyML K-Means function. Now, let's look at a simple example of the K-Means algorithm. Before running the K-Means function, let's review the data used. For this, I'm using the customer segmentation table. Let's run this query. This query will execute in the backend of our UnifyML server. The dataset contains information like customer ID, gender, marital status, age, education, profession, work experience, spending score, and family size. These are the input columns in the customer segmentation table. Now we'll use this dataset to run the K-Means algorithm with UnifyML query. To start, specify the required input table name and input columns, which are the feature columns. You can clean the data using form methods, removing rows with null values, removing duplicates, removing outliers, or filling in missing values. After cleaning, the model is saved for future predictions. Additional parameters available in UnifyML K-Means include input columns, input data types to change column data types if needed, seed for the random seed, maxiter, maximum number of iterations, and input cluster size, which defines the number of clusters. By default, this value is 2. You can also split the data into training and test sets using the train sample size parameter. Hyperparameter tuning is available to generate the best model. There are two types of tuning: cross-validation and train validation. Parameters in hyperparameter tuning include seed, max iterations, and parallelism settings. For dimensionality reduction, the PCA model can be applied by setting the apply PCA model value to true and specifying the input PCA model name. Data scaling options include min-max scaler, standard scaler, normalizer, and binarizer. If the data is saved in the cache, use the input cache ID instead of the input table. Once these parameters are set, run the query. This will execute in the backend of our UnifyML server. The output includes a cluster summary with a number of clusters, training cost, and the number of iterations, along with the saved output model name. Next, we move on to the K-Means prediction process using UnifyML. Specify the input table name and data cleaning methods, such as removing rows, duplicates, outliers, or filling missing values. Then, input the saved model name for predictions. Additional parameters in the K-Means predict function include changing data types, cleaning data, and scaling data. The data scaling options are the same as those used in the training phase. You can also use the input cache ID if the prediction data is already cached. Predictions can be saved to the database using the Save to DB option, or you can overwrite an existing table by setting the Overwrite Output Table option to true. If you want to save predictions as a CSV file, enable the Save to CSV option and specify the file name. Once the input arguments are set, run the query. This query will execute in the backend of our UnifyML server, and the output will show the predicted clusters. The prediction output includes the feature columns and the predicted cluster assignment. Using this method, you can apply the UnifyML K-Means clustering algorithm to any clustering dataset based on your requirements. Thank you for watching this video.